Students, in continuation with last class, today we will learn classification based on the constructional features. Based on constructional features, hydroelectric power plants are classified as runoff river plants, valley dam plants, diversion canal plants, high head diversion plants. Now we will see these types of plants one by one. First one is run-off river plants. These plants are special type of hydroelectric power plants because these do not make use of dams or very large sized reservoirs to store the water. These plants need only a very small sized reservoir to store the water. So, across the flow of river, a very small barrier is constructed, and from the behind of that barrier, the water is taken for generation of electrical power. So to generate power near the barrier, there should be a sufficient head available to generate power. Such plants are constructed only for those rivers where the water flow is throughout the year and with a little bit of seasonal variation. The dominant features of runoff river plants are that they can generate power on the rivers with a continuous flow throughout the year, with a continuous flow throughout the year, with small seasonal variations. Such plants neither have a large reservoir nor do they have a diversion canal of a water away from the main channel. A typical runoff river plant has a powerhouse located with a weir. Weir means small sized barrier it is across the river, behind which water can be stopped, but it will not store large quantity of water. Spanning the river, spanning the river means from one bank to other bank of the river. That also serves as the river flow regulator. So such plants appear like this. Let us consider here one river. The flow direction is towards right here. Across the river, one weir, that means a small barrage, will be constructed. River span means this length here from one bank to other bank, right? And here small gates can be provided so that you can control the flow of water in the river. You can store water for very short duration of time. Otherwise, the water will flow over the barrage. Here we will show a power plant. One small turbine and one generator. So this is our powerhouse. Okay. Water will generate the power by rotating the turbine, and that water, when comes out of the power plant, may be once again be given to the river, and the water that is not taking part in generation of power will keep flowing in its own direction, and this water may be used for irrigation purpose or for the industrial purpose. Next type of power plant is valley dam plants. To understand, first you must know the construction of the dam, and then the position of power plant. So I will draw the figure here now. Just look at the figure and draw it in your notebook. What you see here is the ground at the location of dam. Here it is not plain ground. I hope you all are drawing. Here I have shown part of the dam. It is not yet completed. Now I will complete it. I hope you all have visited dams. This is concrete structure and here is a steel screen. Water will be stored behind the dam, and this water storage, what we call it as pondays. In the river water, there may be any floating matter like wood pieces, metal pieces, small sized stones, etc. If they go into the turbine along with the flow of water, they will damage the turbine. If turbine is damaged, we have to stop the power plant and repair the turbine. That means the power plant cannot produce the power continuously. So there will be interruption of power to the user. In order to avoid that, here a metal screen is placed. Before the water is taken into the turbine, the water is filtered by this metal screen. If any wooden pieces are there, metal pieces are there, they will be getting stuck here only. Only the water can flow through this screen and that water goes to the turbine. The water from the pondage is carried to the turbine by a pipe, and that is called as penstock, or you can call it as conduit. This is called as penstock. In last class also I mentioned penstock. Now here is turbine. Turbine is connected to generator mechanically. This is the floor of generator room. This all together will be forming the powerhouse. And this is concrete structure here, we will hatch it. Here is powerhouse now. So what all you can see here? Pondage behind the dam, screen, gate, dam, then a penstock to carry the water from pondage to the turbine. Here is turbine, and it is coupled at this point to the generator, and generator generates electrical power when its shaft is being rotated by the turbine. The turbine in turn rotates because of the water impinging on it. The constructional part in which there is turbine and generator is called as powerhouse. As the name implies, valley dam plants, such dams are constructed across the river which flows in the valley. That means from the top, if you look at this dam and powerhouse, it would look like the mountains on both sides and the dam constructed here, and the powerhouse constructed at the toe of the dam. The powerhouse will be here. This is all civil construction here. And the river flows here in the valley. Valley is what? It is the space between the mountains. So naturally we will be having there a very good pondage. On either side you need not construct anything using cement and steel, because mountains are naturally available there to hold the water. Only to stop the water, so that the water level increases in the valley, we have to construct one dam, and then after that one powerhouse. In valley dam plants, a dam is constructed for storing the water. Powerhouse is located at the toe of the dam. Why its location is called at the toe of the dam? Reason is, this is dam here. At the base of the dam, powerhouse is constructed. Like we have toe in our foot, the powerhouse is there at the foot of the dam. That is why the location is called as toe of the dam. No diversion of the water from main river is involved. These are of medium to high head plants. The artificial head created will depend on the height of the dam. There are different arrangements of powerhouse location and spillway of the dam. Spillway means it is like a safety wall, like in your cooker, pressure cooker, there is a safety wall. When the pressure increases, that safety wall opens up due to the pressure and the gas leaks out, so the cooker will not blast. In the same way, the dams are provided with the gates. When the dam is full, if there is a chance of crossing the permitted level of the dam due to over raining, then the gates will be opened and the water will be allowed to flow out, so that the dam holds the permitted amount of water only, but not more than that. There are different arrangements of powerhouse location. It means that by changing the location of the powerhouse, if it is possible to get the better head, then the powerhouse may be constructed at other location. Next type of power plants are diversion canal plants. A diversion canal with a flat slope in which the flow from the river is diverted through the canal to powerhouse. The water from powerhouse is drained back into the original river at downstream point. Such one plant I will show here. See, here it is river, so this is river here, and here is a canal which we call as diversion canal for power generation. Across this river, a barrage may be constructed, a small barrage which we call as weir. So the water that is flowing into this river will branch here, and the water that flows into the diversion canal will be used for generation of electric power. And here are the spillways, and you can see here one small powerhouse. Spillway means what? Gates. If water level increases to danger level, then the gates will be opened and the water will flow out. And during normal power generation days also, the water will flow into the river back. So this is river here. After generation of power, the water that comes out of the turbine will join the river water once again at the downstream point. So this is nothing but downstream point. Okay. So after the weir here, the river is said to be downstream, and here it is called as upstream. Before the dam, river is called upstream. After the dam, river is called downstream. A weir is constructed at the end of the canal to create a small pool of water called forebay. That means the space created near the spillway to store the water is called as forebay. The water from forebay is fed by means of penstock to the powerhouse situated in lower reach of the river. In next class we will take up high head diversion plants, and after that we will continue with the main components of hydroelectric power plants. Thank you.